Good afternoon, ladies, or wherever you're at. We're going to do Chapter 1, Day 1 notes. It's Section 1 and Section 2 of Chapter 1. Section 1 is variables and expressions. An algebraic expression is a sum or products of numbers and variables. So sum can also mean subtraction, but it's adding the additive inverse, essentially, and products also can represent division. So the following are examples of algebraic expressions. All right, so they do have variables, right? And I'm going to circle this down here. Variables, it's a little big. Okay, so variables, and that's going to be this x, right? It's going to be this xy, and it's going to be the y, okay? And then it's going to be the x in this one. It's going to be g and g squared, okay? Terms. That's just going to be the term with the variable. So this is a term, this is a term, and this is a term, right? This is a whole term, and then this is a term. This 13, negative 13, is considered essentially a constant, okay? And then again, a term here, a term here, and a term here. Operations. So maybe I circled those operations with the term, right? Our operations, we do have addition here, but we also have multiplication here, right? Ooh, that's looking a little funny. Okay, we do have multiplication. And then we have multiplication right here, and then we have subtraction, all right? So that's typically, algebraic expressions will have all operations, and we have terms, and within those terms we have variables. So when we're going to translate these verbal expressions into algebraic expressions, right, we have to use some of these words. Addition uses these words next to it, subtraction, multiplication, division. So you can use that table to help you translate the expressions into verbal form. So if we are to go down here, you'll have to write this out. I know that. So write a verbal expression for each of the following expressions. And those are algebraic, right? Algebraic expressions. Okay, so here we have something in front of a P. We could say P, or we can say a number. So that is half a number minus 5. Okay, so you see subtraction up there. It has minus. Or we can say half P decreased by 5. We can also say the difference. And you don't have to write all these out, just one or two. Difference of 1/2 a number and 5, okay? So any one of these would be correct. And that is something that on formative, it might show up different. I'm debating on letting it be a matching for what it's going to essentially have, okay? All right, so I think I actually already made the homework. Let's see here. All right, so now we have 18 and we have x raised to the power of 5. So what I said out loud is okay, right? Or we can say 18 times x to the 5th power. Or we can say the product of 18 and x to the 5th power. All right. We could use multiplied too. Excuse me. We can use 18 multiplied by x to the 5th. Okay, this one is 45, right? 45 divided by x. Or we can say the quotient of, and as I did up here, I'm putting 45 here. We should write it out in words, but for time's sake, 45 and x. Okay? So lots of different words there that you have to decipher from, right? I'm going to draw a line here to kind of decipher these. Oh, that's a pretty, okay? All right. And I think that's it essentially for section 1. Oh, never mind. I'm sorry. We now are going to write the algebraic expressions for the verbal expressions. So we have 17 less than h to the 4th power. Okay, so it does use a variable here. And then less than means subtraction, right? And then we have h to the 4th power. Okay, so that means that we have h to the 4th, right? And it says 17 less than h to the 4th power. So whenever it says 17 less than something, it's always going to be minus 17. So if I were to say, you students are 16 years less than my age, you would take my age and subtract 16, right? You wouldn't do your age minus 16. Okay, that would actually get you a negative number, correct? So always try to put it in a real life situation to see if those words work out. Okay, the sum, so we know that's addition, of the product of 3x, okay? So that's probably just 3x and y. So the product of 3x and y. If I were to differentiate that, we have the product of 3x and y. So just like I had up here, the product of 18 and x, right? So those things were next to each other. Same with this down here, okay? 3x and y. So I'm going to have this. Oh, nope, that's wrong. Because, I think the wording here is a little bit off that I had here. So, in this case, the product of 3x cubed and y. But it says the sum of the product 3, it should have, and x. My mistake there. This should have 3 and x. And then we should have the sum of that, so it's going to be plus y. I'll make sure that that's not confusing down the line, that wording. All right, so let's move on to the next one because that one was a little off. 5/8 of the surface area of a prism. Okay, So 5/8, what does that look like? And then we have of. Of means multiplication. And it says surface area of a prism. Yes, you might not know the formula for surface area of a prism, so just put SA because SA represents surface area. So the surface area of a prism is 4 times the base area plus the perimeter times height. No, you're not recommended to know that, but if you did know it, it would be correct to put 5/8 4b plus ph. But this is also acceptable. All right? And in class, I'll go ahead and do some more examples of these sorts of ones that we have, 1 and 2. Okay? Extended practice, write an algebraic expression for the total cost of the car rental. Sally goes to Enterprise Rent-A-Car and rents a car for D days. Okay, so D days. That means for every day, she's probably charged something, right? She is charged $40 per day. Okay, so that matches up. And then, let's use... And then 12 cents for every mile driven, okay? So I used the lighter pink to match up the miles and the D's to match up the days, or the hotter pink to match up the days. So I know if it's 12 cents for every mile, I'm going to multiply 12 cents times the number of miles I drive, right? And then I'm going to add on the cost of days. How many days? It could be either up here or behind. Doesn't matter. And I have $45 per day. And that would be an algebraic expression to represent the total cost of the rental. And no, I'm not going to put equals T because that makes it an equation, not an expression. All right, so again, we'll go through a few of those at the beginning of class on Monday. So section 2 is order of operations. A lot of you have seen this before. There is an order, but one of our essential questions is, does the order of operations have to be done in one specific way? Not necessarily. Yes, we have to use the please excuse my dear Aunt Sally. We have to use PEMDAS, but I can do some things on the same line if there's an operation in between. So I'll show you what I mean by that if I have an example here. My colleague from Village of Shen uses Gemma, and Gemma means group terms, and then exponents, then multiplication and division in that order. So it has to go from left to right. Same with addition and subtraction, left to right. So let's go ahead and do this example. Oh, I keep doing that. So I'm going to keep the 15 there, and I'm going to do what's inside of brackets. 10 plus 3 minus 2 is 1 squared plus 6. Now this is what I mean. I can evaluate this exponent and then add this together in one step, right? So 10 plus 1 squared is 11 plus 6. So I have 15 minus 11, so I got to go from left to right. 15 minus 11 first, which is 4, plus 6 is equal to 10. Okay? And then the next one here, this is another example of, I don't have to essentially do both of the parentheses first. I want to do the top and bottom separately. Okay, so here we have 4 plus 5, which is 25, squared, divided by, oh wait, I'm sorry, I'm like totally 9 squared, right? Oops, what happened there? 9 squared. So 9 squared. And then I have 3 times 7 minus 4, which is 3. So this really doesn't have a left to right situation, right? It has this in the denominator, which I'm going to need to do. 9 squared up top. Let's go ahead and change that to an 81. And then I need to do the multiplication in the denominator, which is 9. And then is equal to 9. Okay? So when you have a fraction bar like that, you usually want to simplify the top and bottom, then do the division. What if there are expressions that should have an S with variables? The variables will need to be assigned some value. So here we have a different value for each variable. So A is 2, and I'll be plugging in 2 to that, right? And then we have B is 6, so I'll be plugging 6 into there. And then I will be having C right here. And I'll be plugging in there. So here we have a division sign now. So things would be going left to right. Okay, so I'm going to have, and we have to put the number in parentheses. So 2 squared times 3 times 6, right? Plus 5 divided by 4. So again, I'm going to evaluate this, but I'm also going to do what's inside of parentheses. I'm going to evaluate this and do what's inside of the parentheses. I'm like pointing at this, thinking you guys can see me pointing, but you can't. So I'm going to evaluate the 2 squared. So that's 4. And then also in the same step, evaluate the inside. So that's 18 plus 5 divided by 4. So that's 4 times 18 plus 5 is 23 divided by 4. Okay. So this is kind of counterintuitive here, right? If we do 4 times 23 and then divide it by 4, right, it's obviously going to be 23. So what I wanted to show you as well is if I had 4 times 23 divided by 4, right, I would complete this first, then divide by 4 usually. But if we see that the 4 and 4 are there, we can cancel them out and just be left with 23. But if I were to go about doing this way, 4 times 23 is 92, and 92 divided by 4 is equal to 23. So you see, we can kind of go both ways with that. And that's why the previous problem we did, we have to evaluate the top and bottom first, then divide, right? Unfortunately, on this one, we did have 9. I'm not even going to go into that because that's going into exponents. So I'm not going to confuse you. Okay, so this is probably the best bet. Oops. to go about doing your stuff in this type of order. Okay, because this part might confuse some. You don't have to write this down, I'm just saying might confuse some. Either way you do it, I'm cool with. Okay, I think last but not least, we're going to do this problem here. According to the California Department of Forestry, an average of 539.2 fires each year are started by burning debris. While campfires are responsible for an average of 129.2 each year. So it says that we want to write an algebraic expression that represents the number of fires on average, D years of debris, and C years of campfire. Let me erase that and circle that with a different color. C years of campfire. So if I come back up here, this represents campfires, right? And this represents debris. So I'm going to go ahead and plug in as follows. So let's do the debris first. So 539.2 times D for debris plus the campfire stuff. And that's 129.2 C. Okay, so how many fires would there be in 5 years? So this again is the years of debris and years of campfire. I plug in 5 for each of those. Okay, and we will have to use a calculator for that. I'm just not going to do that by hand. So this is what I mean by, yes, you're able to use your calculator for stuff like this, but down the line, or just in general, you should know how to multiply operations of fractions and decimals on your own, okay? Okay, so it looks like there will be 3,342 fires each, or after 5 years. In 5 years. After 5, we'll say after. Okay? All right, that's it for today. Again, in class on Monday, we'll go ahead and do some more practice with order of operations before you get started on your homework. Have a good rest of your day.